Download this code from codegive.com, link in the description below. Sure. Let's dive into the concept of a perceptron and boosting, along with some code examples. Perceptron. The perceptron is one of the simplest types of artificial neural networks and serves as a fundamental building block for more complex models. It was introduced by Frank Rosenblatt in 1958 and is primarily used for binary classification tasks. Structure of a perceptron. A perceptron consists of inputs, features of the dataset. Weights, each input has an associated weight that adjusts as learning occurs. Bias, an additional parameter that allows the model to fit the data better. Activation function, a function that determines the output of the perceptron based on the weighted sum of the inputs. The most common activation function is the step function. Perceptron algorithm. 1. Initialization, start with random weights and bias. 2. Weighted sum, calculate the weighted sum of inputs. 3. Activation, apply the activation function to determine the output. 4. Update weights, adjust weights based on the prediction error. 5. Repeat, continue the process for a set number of epochs or until convergence. Code example, Perceptron in Python. Here's a simple implementation of the Perceptron algorithm in Python using NumPy. Boosting. Boosting is an ensemble technique that combines the predictions of several base learners to improve overall model performance. The idea is to focus on the errors made by previous models in the ensemble and correct them in subsequent models. How boosting works. 1. Initialize, start with the original dataset. 2. Train a model, train a base model on the dataset. 3. Compute errors, identify the samples that were misclassified. 4. Update weights, increase the weights of misclassified samples so that they are given more importance in the next iteration. 5. Combine models, the final prediction is a weighted sum of the predictions from all models. Loss function in boosting. The loss function typically used in boosting is the exponential loss function. It penalizes misclassified points more heavily. Code example, boosting with AdaBoost. Here's a simple implementation of AdaBoost using the scikit-learn library. Summary. The perceptron is a basic neural network model used for binary classification, adjusting weights based on errors in predictions. Boosting is an ensemble technique that combines multiple models to improve accuracy, focusing on correcting misclassifications. In both examples, we provided a practical implementation to demonstrate how these algorithms work. Feel free to ask if you have any questions or need further clarification on any topic.